Okay, to pick up off where we left off, and once you, this is N-butyl right here, and here what you have to do is distinguish from between these two right here. So this is called sec-butyl when this is attached to this particular carbon. If it's attached so that you have this methyl group out here attached to this middle one, and it's attached to this one over here, this is called isobutyl. And this right here is called, and if instead of bonding to here, if it bonds to this one, it's called tert-butyl. But those are some specialty things for the iso and the sec and the tert in terms of in describing where these are bonded. There's the way in which we talked about it before in terms of numbering them and all of that. That will be the general way in which they are described in the textbook and other places. This right here is just if you happen to encounter one of these other names, I just wanted you to be able to understand, yes, this is the sort of thing that they're talking about. So here you have ethene, would be the way it would normally be pronounced, but we call it ethylene. This would be propene, and this is, or propylene. Now, on this one right here, it doesn't matter whether it's double bond is here or double bond is here because you're counting from the same thing. Here what you're doing is this is, once you get out to more than that, this has to be 1-butene, and if it's here, it's 2-butene, right? You try to get the smallest number out there as possible, but it doesn't matter whether you start counting from here, this side end, or this end, this is going to be 2-butene. If you were, this would be 3-butene if you started counting from this way, and that's a much larger number, so we don't want to do that. And this right here shows 3 different structural and geometric relationships. If the double bond is here, it looks like this. If the double bond is here, you can see it's a very different looking molecule. And if it's located here, it looks like this. Okay? So, very different ways in which these things will look, depending upon their orientation. So anyway, these are both 2-butene, but you have a cis one where both of these are on the same side, and you have the trans where they are opposite each other, right? So this is where cis and trans comes from, and this is a correct use of those words. Now, when you have a double bond, it's very easy to have a reaction, and from that type of molecule, that's how you get the 1,2-dichloroethane, is by reacting chlorine with that. You can break that bond and form these single bonds. This is ethene or acetylene, and this would be 2-acetylene, right? Now this one right here is a little bit different. When you have both a double bond and a single bond, what happens is the double bond and a triple bond, the double bond takes precedence in terms of the name in which it occurs. However, the numbering of that starts with where the triple bond is located. So this particular one, and these molecules, by the way, are called alkenes. Alkenes. A-L-K-E-N-Y-N-E. Okay, I don't think you'll find that in your textbook, but that's a special one. I just thought it was interesting to look at. So this one right here, you start with the name, and so this would be a 3-pentene 1-ine. So you can see how they have the alkene-ine name to them. And it's called that way because this one goes first in the name. So this would be 3-pentene, P-E-N-T-E-N, 1-ine, Y-N-E. Okay? Oops. Sorry. wanted to skip around there. As we mentioned, the benzene ring with these, it's it is arranged so that it goes back and forth between these two transition states. And this is a condensed version of that. Sometimes they just show a circle here. Sometimes they will show 3 bonds and just assume that you know that it's resonating back and forth between the two forms. When you have the ones off of here, wherever that first one appears, that becomes your first one. That's number 1. So this would be toluene or 1-methylbenzene. And this is with 2 methyl groups on there. So this is xylene, or the other name would be 1,2-dimethylbenzene. And here you've got an ethene group up here, CH2. And so this actually is the formula for styrene. So when you form the polystyrene molecules, polystyrene is this right here, just polymerized, so you have a whole chain of these. And this example right here, we'll start with toluene. So that, and when something is right next to it, it's called ortho. If it's in another position over, it would be called meta. And if it's way on the other side, it's called para. Okay, so this would be 2-chlorotoluene, right? And this would be, or orthochlorotoluene, and this would be parachlorotoluene, right? Now we'll talk about where you have functional groups on those different hydrocarbons. One of the simplest ones is an OH group, a hydroxyl group, right? But this is not like you had when you were talking about bases. This is a covalent bond here, a covalent bond. So this is not an ion of any sort. If it's a methane group, becomes methanol, right? Methyl alcohol. An alcohol group on an ethane group is ethanol or ethyl alcohol. This is N-propyl alcohol. This is isopropyl alcohol. Okay? So you see, depending upon whether this is where the N and the iso come into play. It's on the center one here, so it's iso. It's on the N, so it's an N. N stands for normal. Yes. There's a way that alcohols can be formed. The one most common in use is to take glucose from corn or from some other product, organic product, add yeast to it, and you get ethanol plus carbon dioxide, right? This is where you have the carbon dioxide in the beer. You don't have it in the wine because of the different process. There's another way, industrially, you can heat it up in acid with water to form an alcohol in this manner. There's also the possibility of having more than one alcohol OH group on there. If you have, this is just ethanol. If instead you have 2 of them, this is ethylene glycol. This is common for antifreeze. And if you have 3 of them right there, this is glycerol, right? And this, there should not be a space here. So 1, 2, 3, propane triol, right? You see the diol in here. So the glycol, this is a common name. This is the official chemical name in both cases. And there's no space here. So this is 1,2-ethane diol. This is 1,2,3 propane triol. We have OH groups on sugars, right? And so this is what fructose would look like. This is what lactose looks like. This is the 5-carbon monosaccharide. This is a disaccharide. And you have 1, 2, 3, 4, 5, 6 elements there. You have 6 here. So this is 2 glucose molecules together forms lactose. And diabetes is just high concentrations of glucose and a test for that. Okay. In addition to the chlorine groups or halide groups, we also have alcohol groups. You can also have an ether where you've got the R here stands for a carbon element in a carbon chain. So if you have an OH attached to a carbon, it's an alcohol. If you have an oxygen between two carbon atoms, it is an ether. If it's a carbon with a double bond to an oxygen in the middle there, with a hydrogen over here, it's an aldehyde. If you have a double bond with carbons on each side of that carbon, it's a ketone. If you have a double bond and then this carbon is attached to an oxygen with an OH, with an H there, this becomes an organic acid. Okay, this bond right here is somewhat covalent, but it's possible to ionize this. Okay, if you have a carbon instead of a hydrogen there, it becomes an ester. And an amine is when you have a carbon attached to a nitrogen. We'll talk about each one of those in a bit more detail. This right here is an ether, right? And it would be, you would have 1, 2, so you would have 2, and it's 1, 2, 3, 4, right? And so that would be a butane. So it would be 2 butane ether, right? Here you have ethanol plus an ethanol, and you get rid of a water molecule with sulfuric acid and heat to give you a diethyl ether. Let's go on to carbon group, functional groups. This is called a carbonyl group. If you've got a carbonyl group with a hydrogen attached to it, it's an aldehyde. If you've got a carbonyl group with 2 carbons attached to it, it is a ketone. Formaldehyde would be this compound right here, where you have, instead of an R or an H, you have 2 H's here instead of a carbon. And propanone here is an acetone, where you've got a carbon here and a carbon here. And so this is acetone, this is formaldehyde. 2 very common materials, and these are their common names, but of course as chemists, you can put on an error or two and call it methanol and propanone, okay? These end in AL, as opposed to the alcohols which ended in OL, right? And this ends in ONE, okay, instead of an ANE. So endings are very important. So this is the functional group of an aldehyde. This is the functional group of a ketone. This is an aldehyde, acetaldehyde, ethanol, right? And this is butanone right here. And you'll find out that this is a ketone. And these are the way they're formed. You take an alcohol, an OH group, you oxidize it. The oxidation will cause that carbonyl group to form. Okay? Now, organic acids and esters. We've talked about organic acids and how they are weak acids. In other words, you can take this hydrogen away to some extent, but not entirely. The general formula for that is RCOOH. Formic acid, which comes from the sting of ants. Acetic acid, that's the vinegar. Citric acid are all different organic acids. If instead of this hydrogen group here, you replace it with another carbon attached to it, and it can be an acetate right here, like this one. It can be so this is an amyl acetate. This is an amyl group right here. This is acetic acid with an amyl group over here, C5H11. This is an octyl group here, and this one right here has a banana flavor. This has an orange flavor. This has a pineapple flavor. So the flavorings that you get when it's artificially